So our aim for today is that we are going to be able to find the area of complex figures. Now there's a lot that goes into finding the area of a complex figure. So for instance, if we wanted to find the area of this figure, Kip yes or Kip no, do we have a formula for the area of an L shape? Absolutely not. But what we can do is we can go ahead and break that shape down into things that we do know how to find the area of. So for instance, we could break this down into two rectangles by just cutting it apart like this. Now I see that I have a rectangle 1 and a rectangle 2. However, one thing that we're going to run into a lot of is that the dimensions that we need for those rectangles aren't going to be totally given to us. So for rectangle 2, it's very obvious we have the length and the width of that rectangle, but for rectangle 1, the length and the width are not given to us. However, enough information is given to us to allow us to find x and y, those lengths and widths of that rectangle. Is there anybody who looks at this and automatically thinks to themselves, I know how I can find one or both of those values? Manuel, what do you think?
You add 7 inches to 15 inches.
So, to get what? The length of the bottom, the x, okay? So he's saying add 15 to 7. So I see the 15 and the 7 that you're working with. Can you explain to me and the rest of the class why you're able to add those together to get the length of x?
Because it's the same width or length I don't know.
So the first thing that I'm hearing Junior tell us is that this length at the top of this rectangle that we've created is the same as the length at the bottom. That's the first thing that I hear him telling us. Okay? Because they're opposite sides of a rectangle. The second thing that I hear him telling me is that from here to here is 15. And the reason why we're adding 7 is because we know this length from this beginning point to this end point is 7. How did you know that, Manuel? Right, because the 7's on top, and opposite sides of a rectangle are the same. So this entire length from one end to the other is 15 plus 7, which is 12. So x is equal to 12. Just kidding. Thank you for showing me, Kip. No, you know 15 plus 7 is actually 22. I was just testing you. Juan. So I hear Juan thinking about this other one. He's starting to draw this relationship between this y, which is vertically oriented, and the other end over here. He's saying this is y. And he wants to divide by 2. And I think that would be great, and I think that would be awesome if we knew that that was directly in the middle, if we knew that was a bisector, or if we knew that was a midpoint. But unfortunately, there's nothing in this problem that tells us that that's a bisector or that's a midpoint. There is one piece of information, though, that can help us sort this out. Rebecca? And where does the 9 come from? Okay, so she's looking over here on the left side, and she's saying, since I know this side of this rectangle is 9, and my new rectangle, I know this side is 9. If the entire thing is 15, so I know the 9 plus the y is supposed to be 15, some of us may want to write out that equation really quickly just so we can think about it more mathematically rather than just so visually. It says 9 plus y is 15. So what does y have to be? Michael, what does y have to be? 6. Okay, so this is a basic skill that we have to be able to complete in order to even start thinking about our aim for today. Let's look at some more examples. All right, On this one, it's asking us to find x and y, where x is our length over here, and y is this length of horizontal stuff in the middle. Does anybody have any ideas about finding x or y in this particular problem? Juan, what do you think? Where did the 8 and the 16 come from? Okay, so Juan is taking his 16 and he's basically drawing this idea of like, this is kind of like he's cutting here and cutting here. And therefore making this rectangle and telling me the opposite side is 4. The opposite side is 4. And he's saying, well, what's left is the same thing as this x. So 4 plus x was equal to the entire length, which was 16. So 8 plus x is 16. Mathematically, if we solve that, that's the 16 minus the 8, which tells us that the x is 8. That was actually the more difficult one. Good work, Juan. So what about the y? Malcolm. Okay, why is the y 8? Why is the y? So he's kind of thinking about this as one giant rectangle and saying, well, if one side of this rectangle is 8, then the other side of this rectangle is 8. And that's perfectly logical thought. What am I missing on actually all of these problems? Marlon? Units. Come on, Mr. Boots, get those units in there. Yeah, units are so important that they're in red, to draw your attention to it. All right. One last one. So for this one, we have this broken apart into a triangle and a rectangle, and we need to find the base and height of the triangle. Let's start with some ideas about this one. One of them is actually super easy. Katie. Again, there's nothing in here that tells us that this is a bisector. By bisector, that means split evenly in two. If it tells us that it's a bisector, then we can divide by 2. Or if it tells us that's the midpoint, then we can divide by 2. Otherwise, we have to use other relationships that are given to us. Raisa. Raisa knows what x is. Raisa, what is x? Malcolm, what did she just say x was? Kendrick, what did she just say x was?
6.
Okay, that's the thing, is you actually don't know who answered that question. Alright, so looking at this, how do we know that x is 6? Maureen. Yeah, so it's opposite sides of a rectangle. Alright, so that's the x. What about the y? Julia, what about the y? Where'd the 7 come from? So the top, she's saying, is the opposite side. Down here is 7. So that means 7 plus this y is supposed to be our 13. So again, you can think about it as equation. 7 plus y is 13. So that y is going to be equal to 6. These are our centimeters. Now, kip yes or kip no. Is our aim for today, Kipsters will be able to find unlabeled sides of complex figures?
Yes.
No.
Yes,
Let me say that again. Is our aim today, Kipsters will be able to find the missing sides or unlabeled sides of complex figures? No, our aim today is that Kipsters will be able to find the area of complex figures. So what we just did is only a small piece of our work for today. It's a piece that you have to be able to do in order to even start working on our aim today. So, as we look over here, we've got this shape that is a complex figure. In other words, a shape that we don't have a formula for. But we do have a way that we can break this figure into things that we do know how to find the area of. Jose, what are we going to do?
Split it to a square and a triangle.
It's not going to be a square,
put triangle there.
but it is going to be a rectangle and a triangle. Now, looking at our two shapes, I'm going to label one of them shape 1 and one of them shape 2. Shape 1 is a rectangle. Shape 2 is a triangle. What is the area formula for a rectangle?
What?
Kenneth.
Oh.
Area equals base times height, length times width. It's generally the way we talk about it, though. And what is the area of the triangle, our second shape? What is our formula for that? Janelle. Equals base times height divided by 2. So that means for shape 1, that tells us we need to find a length and a width. And for shape 2, we need to find a base and a height in order to solve those equations for the areas. What are the length and width of the rectangle? Kevin, what are the length and width of the rectangle? Yeah, so this one's really easy. We have a length here of 12 and the width is 10. So we have length of 12 and width of 10. Now, looking at our triangle, I need the base and the height. Neither of those things are directly labeled for us, so we have to do some of that work that we were talking about on the other side. Let's start with this one, and let's call this the base. This is the easier of the two. What is the base length of this triangle, and how do you know?
10.
Nicole? Yeah, it's the opposite side of a rectangle, so it's the same. This is 10. Now, what about this height? One.
No work in credit.
Sorry, what about 12 and 25? Subtract 12 and 25. Why?
6 more. I know, but thank you. Give me this.
Why? Sorry, Juan, you were interrupted while you were explaining. 12 and 25. You said subtract them. Why? So I hear you saying something about this length from here to here. What do you know about that length? Raisa, help him explain. So that's 12. and the entire thing is 25. So our unknown here that we're trying to find out is 12 plus x equals 25. And so if we wanted to solve this, we would be doing 25 minus 12. So the height of our triangle is what? Fernando? 13. I'm concerned right now that all of you aren't coming up with this on your own. Okay? This is work that if you are not able to find the dimensions yourselves to begin with, you can't even begin solving for the area. So I'm concerned right now that I don't see a lot of hands shooting up. So either you're not participating, which is not good, or you don't know, which is also not good. Right now, I have to assume that you don't know. Please make sure that you make it clear to me while we go through the next problem that you understand or you don't understand. Because if you don't understand, you should be asking questions. All right, so if I want to find the total area, I need to find the area of shape 1, which we said was length times width. We said the length was 12 and the width was 10. So that tells us the area for shape 1 is what? Sarah? 120. I also need to find the area for shape 2, which we said was base times height divided by 2.
What the heck?
Our base was 10. Our height was 13. So that's 130 divided by 2. Which gives us an area of 65. Now, was my goal here, was my end goal to find the area of these two individual pieces? Did it say, break this into 2 parts and find the area of each? No, our goal here is to find the area of the whole thing. How am I going to find the area of the whole thing? Rebecca, add them together. Find our total area. So 120 plus 65 gives me 185 units. Nicole? Square centimeters or centimeters squared. Okay. Next one. Again, we see this L shape. How can I break this L shape into pieces that we can find the area of? Adriana. Two rectangles. Now, which way did you cut this? Okay, I see that she cut it like this. Is this the only way we could have cut this and ended up with two rectangles? No. It does make a small amount of difference. We can answer it either way. This way, the way I think about it is I look at this and I see if I cut it this way, I need the length and width, which are both given to me, and I need the length and width. Only one of those two is given to me. If I come back through and I cut it this way, I look at the two rectangles that I need. I have the length and width of one rectangle, but I don't have the entire length or the entire width of the other rectangle. So which one probably is going to be a little bit easier? The first way that we did it or the second way that we did it? Maureen? Probably the first way. Again, you could have done it either way. This one's just going to require a little bit less work in terms of finding the dimensions that we need. Make sure that you label shapes 1 and 2. Shape 1 is a rectangle. Shape 2 is a rectangle. So the area for shape 1 is length times width. The area for shape 2, it's a rectangle, so it's length times width. So that means for each of these, I need a length and a width. Starting with rectangle number 1. Fernando, what are the length and width of rectangle number 1?
Our length is 27.
Mm-hmm.
And our width is
27 and 6. Perfect. Looking at rectangle number 2. What are our length and width of rectangle number 2? So it's going to take a little bit more thought. Sania. Okay, so you say the length is 8 and the width is 9. I definitely see where the 8 comes from. What I need you to explain to everybody else is where the 9 comes from. So she's saying the entire length here is 27, and she needs to take out the 18 to leave what's left over for this width that she was solving for. Kip yes or Kip no? We understand where the 9 comes from. Kip yes or Kip no? You can do that on your own.
Yes.
Just one more quick clarification. She said that this entire length all the way from one end of this long rectangle to the other was 27. She knew that this first longer part of it was 18. And she was looking for the other smaller part of it. That was going to be the width of our number 2 rectangle. So she said if they're both supposed to add up to 27, the 27 is equal to the 18 plus the W. Okay? If you want to solve that equation, you're going to end up subtracting 27 minus 18. That's where the 9 comes from. Any other questions about that? Yes, Fernando? So at this point, we haven't gotten our final answer because we haven't even started calculating areas, right? So we need to find the areas of the 2 shapes that we broke it up into. Area 1, so let me switch back to blue. Area 1 is equal to length times
Boots.
width.
Boot.
Length times width, we said the length was 27 and the width was 6. So now we've got to do 27 times 6. I'm going to do that work down here real quick. I get 162. And I also need the area for shape 2, which we said was a length times width. And we said the length and width were 8 and 9 over here. So area 2 is equal to 72. Are we done yet?
No.
Not quite done yet because it didn't ask us find the individual areas of the different parts of this shape. It said find the total area. How do I find the total area from here? Brian, how do I find the total area from here? How do I find the total area from here, Raisa? Add. So we have the area from figure 1, the area for figure 2, add them together, 162 plus 72. And I should get 234 units. Fernando? Kip yes if you agree, Kip no if you do not. Adriana? Talking about area. You gotta square those units, all right? Fortunately for us, we're not done yet. We get some more teacher time to do. All right, so for these problems are going to require this idea of negative space. Now, I'm not saying there is a vortex in the middle of the room that creates this negative space that's like actually takes away from space. There's really no such thing. You can't have such a thing as negative space. However, in our definition of negative space, the way we think about negative space is it's space that was taken away. In other words, it's area that's taken away.
Your school was taken away.
Area that is taken away from a larger area.
Good.
So, the way that we're going to use this particular concept is we're trying to find the area of the shaded region here. Well, I could take the shaded region and I can break it up into rectangles and triangles by doing this. Okay, so now I have 1, 2, 3, 4 rectangles. But because of the way this one's set up, we can use this idea of negative space, and we can think about it this way. Once upon a time, I had a giant pan cookie. It was a giant rectangular cookie. And then some punk, Kendrick, came along with a cookie cutter and
Shut up, Tubby.
took out a big chunk of my cookie.
So I cut your cookie, sucker.
That's correct. You cut my cookie. So you removed some of my cookie. You took it away. So the question is, we can do this problem and we can think about it that way. Well, I had original shape. Originally I had a rectangular cookie.
Now yeah.
And a second shape, this cookie cutter that Kendrick came in with, was also a rectangle. What were the dimensions of my original cookie?
What do you mean?
If I wanted to find the original area of my cookie before Kendrick came in and took some of it away.
You gotta add on more.
Manuel, what were the original dimensions of that cookie?
12, 25.
12 by 25. So we can see my original cookie was a rectangular that was 12 by 25. Then Kendrick came in with his rectangular cookie cutter. And what are the dimensions of what he took away? What are the dimensions of his cookie cutter? Madeline? 12 and 10. So I see 12 and 10 for what he took away. So the area that I originally had was 12 times 25. Was 12 times 25. So originally I had 300 square centimeters of cookie. Delicious. Unfortunately, Kendrick came out and took out his area, which was 12 times 10. He came and took 120 square centimeters of my cookie.
That he paid for.
He did pay for it, so I guess that's fair. How much area of cookie did I have left? How are we going to sort that out? Katie? Subtract it. So I had 300. Kendrick came along and took out 120. Left me with 180 square centimeters. Right? As we look at the next problem, I could take this problem and I could break it into, let's see, that's a triangle for this shaded part and 2 rectangles. But then I have to find all these dimensions. However, I can think about this as a negative space problem. If I think about this as a negative space problem, what would be the original shape of my cookie? Michael? Rectangle. This big, giant rectangle. This would be my original cookie. That would be our shape 1.
Give me some cookies, please.
So we need an area equals length times width. And what are the dimensions of my original cookie? Maureen? 25 by 10. Now, what shaped cookie cutter did somebody come along with?
A rectangle. No.
Marlon. Triangular cookie cutter right down here in the corner.
Who cut the cookie from the cookie jar?
So what's the area formula for that cookie cutter? Manuel?
Base times height divided by
Base times height divided by 2.
Who took the cookie from the cookie
So I need a base and a height for that triangle. What are the base and height of the cookie cutter? Graciela, what are the base and the height of the cookie cutter? 3 and 3. So now let's go ahead and find the area of my original cookie was area equals length times width, which was 25 times 10. That's 250. Originally, I had 250 square centimeters of cookie, but somebody came along with their cookie cutter and took out base times height divided by 2.
What was that?
That's 3 times 3 divided by 2, which is 9 divided by 2. So A2 is equal to 9 divided by 2.
Mistake.
4.5. I'm going to find out how much cookie I had left.
You subtract.
Cool. Subtract. Now be very careful with the subtraction. Make sure you got it lined up properly. This is 250. This is 4.5. I need to throw on an extra 0 there so my decimal points can line up. Borrow. Borrow again. 5, 5, 4, 2, decimal straight down. 245.5 centimeters squared. Okay, so we can use negative space for some of these problems. It's going to be quicker. We could have, all these negative space problems that we did, we could have done those problems by breaking all those shaded areas up into triangles and rectangles, but it was a lot easier to think about them as negative space. So It's a matter of choosing what things work best, okay? Are there any questions about any of the work we've done today? The complex figure areas or the negative space areas? Marlon?
So, in this one, we have to subtract and the other one we have to add.
Right, it depends on how you're working with the problem. For these problems, we were thinking about it as a larger space and that something had been taken away. Whereas in the other problems, we were thinking about this is one large space, but I'm breaking it into two pieces so I can find the areas and the areas to put them together. Okay? So it just depends on how you're looking at the problem. There's no difference. You could have taken one of those problems earlier, and that was an L shape. And you could have said, well,
Maybe.
maybe this once was a large rectangle, and this smaller rectangle was taken out of it. You could have treated that problem that way. It just depends on what works best for you, okay? Looking over at your together time. Well, guess that's just going to stay there. Look on over at your together time.